Hello guys, so in this video we are going to say this problem, create binary tree from description. So let's see the problem. What it is saying is you are given a 2D integer array descriptions where description I, that is each element, will have these three values, parent, child and is left, indicates that parent I is the parent of child I in a binary tree of unique values. So this is the keyword unique values, and furthermore if left is equals to 1, and so it means that it is a left child, and if left is equals to 0, it means that child is the right child of parent. So if you see this example, so what it is saying is 15, which is a child, and what type of child it is the left child of 20. So what we have to do is we have to create 20, put 15 on the left side of it. Then we have to see 17 is the right child of 20. So 17 is the right child of 20. 20 is the left child of 15. So 20 is the left child of 50. And then 80 is the right child of 50. 80 is the right child of 50. And then 19 is the left child of 80. So 19 is the left child of 18. So this is what we have to create. So let's see how we can go ahead with this. So I have taken this example here. So I have also considered this map here. If you see, this map will store the values of the number since they are unique, and their corresponding references to the nodes that value is there in. Now we have to, this is the parent, this is child, and this is our whether left or not. So first we are here, so we will see 15 we will have to add to 20. So we'll first have to see whether 20 is there or not. So for that we are going to check this map. So map, we do not have any entry as 20, so what we are going to do is we are going to create 20, and then we have to insert into the map. Okay, so 20, and this reference is 20, for example. Okay, now we are going to see whether 15 is there or not. So 15 is also not there, so we are going to create 15 and add that reference here. And once we have created both, then we are going to add to the 15 to the left of it. Similarly, when we come here, 20 is there, okay, 17 is not there, so we are going to create 17 and attach to right side of it and put that value in map. Similarly, for 50 20 we will see, okay, 50 is not there, so we will have to add 50. Then 20 is there, yes, 20 is there, so what we are going to do, we are simply going to add it, and we will not to create 20 again. We'll come here, we'll see, okay, 50 is already there, parent is there, child is there or not. So 80 is not there, 50 we have created here. Okay, so let me add it here as well. Then we'll come to 80. 80 is not there, let's create 80 first. 80 first is created, put it into the reference and add it to the right side of 50 because here it is 0. Then we'll see, okay, 80 is there as a parent, 19 is there as a child or not. Okay, not there, so we have created 19, we have put it into the map, and then this one is there, so what we are going to do, we are going to add 19 to the left of 80. So this is what we are going to get. Now what we have to do is we have to return the root of this particular array or this particular tree. So how we can get the root? If you see this particular each element, so how this each element is given is like this. The second element is the child. Okay, now since 50 is the root, it is not a child of any one of this. It means that if we iterate over this array over each of this element, we cannot find 50 in this first position. So what we are going to do is we are going to take this 15, this 17, 20, 80 and 19 in a set, or you can basically say hash set. So in the hash set, what we are going to do is we are going to give 15, 17, 20, 18, 19, and in the map what we have done is we have already stored all the numbers or all the nodes that we have created. It means that all of these will contain the root as well. So what we are going to do, we are going to iterate over this map, and we see, okay, 20, is it there in the hashtag or not? So it is there, so it cannot be the root. 15 is there in the map, if it is there or not, it is there, so it cannot be root, because if it is there, it means that it is child of some node which is not for the root. That is why we are neglecting those. 17 is there, so cannot be. 50 is not there in the hash set, it means that 50 is the root, and we have to return the reference of that 50. So that way we can get the root of the tree as well. So let's see the code. There's nothing much about the code. Is it definitely looks big, but the thing is, I'll explain the first part only, and the second part is the same. So the first part, if you see, we are checking whether the parent is there or not. For each description we are checking whether the parent is there or not. So in the if statement we are checking if parent present. If parent present. If it is present, then what we are going to do is we are going to check whether it is left or right. So we have that if statement which checks whether it is left or not. If it is left, then what we are going to see is we are going to check whether the child is already created or not. So then we are going to say if child created or not. If it is created, we will add like do parent, which is by getting this dot left is equals to the child if it is already created. Else what we are going to do is we are going to create a child, then we have to assign it to the left side of the parent, and then we have to update the map as well. So these three things we are doing here. If the left, it is left side. If it is right side, then all we have to do is in case of this left we have to replace it with right. That's it. If you see here, this left is there, then the right is there, right is there, so everything else is as it is. Okay, now if suppose this is the case where the parent was present. Okay, suppose the parent is not present, so basically what we have to do is we just have to create a parent first, then everything that is there will be same here as well as it is. So just these two lines are more as compared to the other if statement, and everything else is same. Now as we have discussed how we are going to get the root. So if you see here, since we have already created the map, and in the map we have just a second, we have put 20, 15, 70, 50, 80 and 19. So what we are going to do is we are going to iterate over this description. So if you can see here, and putting the first index value each of this in the set. Okay, because these are the childs and 50 cannot be child or the root cannot be child, so let's keep all the child in a set and then iterate over all the key set that we have in the map, because it contains the root one as well. Now for each of these we are going to check whether it contains in the set or not. If it does not contain in the set, if it does not contain, then that is our root and that is what we are going to return. Okay, so this is it. The problem is quite simple. Let's try to submit this question. So if I'll submit this, let me go ahead and check this again. Just a second. So yes, so this is what the code is already submitted. So I hope this question you have understood, and let me know in the comments if you have any doubts. Okay, thank you.